there, algebras. Welcome to chapter 8, where we are going to solve quadratic equations. And yes, this is part 1 of 2 solving quadratic equations chapters. In this quadratic equation, or excuse me, in this solving quadratic equations chapter, we are only going to solve quadratic equations by factoring, which is why the entire chapter 7 was all about factoring. So then we could get into solving quadratic equations using that method. So today I'm going to start talking about chapter 8, lesson 1, which is all about standard form of quadratic equations and something called the zero product law, which I will get into. Then, of course, we move into solving quadratic equations by factoring the whole deal of basically the entire chapter. We'll do that in standard form and non-standard form. We'll review and quiz. After the quiz, we will apply this method of solving quadratic equations to word problems that will result in quadratic equations. Then, of course, we will review and have a test. Okay, but that's really the whole deal in this chapter is solving quadratic equations by factoring. All right. So before we can do that, we need to talk about standard form of a quadratic equation, how we can tell when we have a quadratic equation, and something called the zero product law, which actually is exactly what you think it's going to be. Okay, so there we go. Let's talk about how we know we have different functions. So it's going back to chapter 3 when we talked about functions in general and what were our different types of functions, excuse me, that we have to be able to recognize. The first type of function listed here is an absolute value function. And I can tell because the bars around my x are straight up and down. So I know that this is absolute value. Okay. Here, we know we have a linear function because if you look at the x, the only thing happening around it is adding, subtracting, or multiplying. If you have anything else happening around your x, you don't have a linear function. So this is what we like to call a linear function or a line because we've got a slope and a y-intercept here. Next, because x is actually the thing in the exponent, we call this an exponential function. So this is when the variable is the exponent, and that's what changes throughout all of our changes in our function. Every time our x changes, our y changes and matches, but the x is actually the exponent on a base. That's why we call it an exponential function. Lastly, when you have an x squared as your highest present exponent, we call that a quadratic function. So which of these was the quadratic function? That would be D. I did take the time to list out all the other types of functions that we need to be able to recognize. There's a couple more too, cubics, cube root, square root. Those are other types of functions we have to be able to recognize by their equation. The simplest form for a quadratic expression here, so not equation, is ax squared plus bx plus c, where a cannot equal 0. And the reason we say a cannot equal 0 is because, well, if the a value were 0, there wouldn't be an x squared here, and you wouldn't have a quadratic expression. So that's why we want to be kind of careful about making sure to say, well, a has to be there. Has to at least be a 1, if not something more or less, but it can't be 0. And you don't have a quadratic. And I want you to note the difference between this expression and down here where we have an equation is ax squared plus bx plus c equals 0. Look at that subtle difference. In chapter 7, we did not have equations. We were factoring, simplifying, standard forming expressions. Now we have equations. And if there's an equal sign and a number on the other side, we solve for x. So now we're going to go through and get answers for x. Okay, that's going to be the plan here. What we're going to do, the first thing we're going to do is just get standard form of our quadratic equations. I know we practiced this in chapter 6 and in chapter 7, but again, now because there's equal signs, we need to be extra careful. And one of the things I'm going to hint at throughout this entire chapter is keep your x squared term positive. While when we get to chapter 10 and we solve quadratic equations in other methods, we can have a negative x squared. We prefer not to when factoring. Okay, when factoring is our method of solving, we prefer not to have a negative x squared. So let's try to keep our x squareds positive here. And let's scooch this 6 over to b with our positive x squared and our negative 5x. Because remember, standard form is going to be ax squared plus bx plus c equals 0. So we want this side to be a 0. So we'll subtract that 6 from both sides of the equal sign. The x squared term comes first. The x term on its own comes next. Then the minus 6, the constant at the end, and now equals 0 because 6 minus 6 is 0 over here. And that will be important in the second half of this lesson. Number 2, I want you to notice that, yeah, our x squared is alone over here, but it's negative. I want it to be positive. That was what I had kind of mentioned, right? I want to move it by adding, and what that does is it makes my x squared positive for me. Now notice where I put it kind of off to the side in front of that negative 6x because standard form means descending exponential order. Your ax squared, then your bx, then your c equals 0. So x squared, then minus 6x, then plus 5 equals 0. That's our standard form so far. Now, of course, in 3 and 4, we don't currently see an x squared, but we also have an x on the outside of parentheses with a binomial inside the parentheses. So that means we need to distribute first, so we end up getting our x squared. Then we can do the rest of standard form. So x times x is, of course, x squared. X times 2 gives me my plus 2x. Now I bring down my equal sign and my 35. Well, I've already got a positive x squared on the left-hand side, so let's subtract that 35 from both sides. And that 35, of course, needs to go at the end here. So x squared plus 2x minus 35 equals 0. So here's my standard forms so far, right? And this is the first thing we'll do on the homework too, is have the standard form. And then, of course, here, distribute the x throughout the parentheses. X squared minus 8x equals 2x minus 25. And again, because I'm trying to keep this x squared positive, that tells me that these are the terms I want to move to the other side of the equal sign. So we move those things across equal signs by opposite signs. So the minus 2x is going to line up with the negative 8x. This plus 25 is going to be at my end here. X squared minus 10x plus 25 equals 0. Okay, so stop there. Make sure you understand standard form. Make sure you recognize standard form. Okay, that's the idea, is we want one side equal to 0. We want a positive x squared on the other side. Okay. All right. The zero product law, ZPL. And it says exactly what you think it's going to say. If two things multiply together and their result is 0, then one of those two things needed to have been 0. Okay, so just real quick, we had factored a lot in chapter 7. Okay, we had factored a lot in chapter 7. We want product to be 12 here, right? And that would be like 3 and 4, like 2 and 6, like 1 and 12 multiplying together. If you're trying to do that for 24, you can do like negative 3 and positive 8, or positive 8 and negative 8 and positive 3, right? Just kind of flip signs for those. What about 1 and 24? One of them's got to be negative, so let's make the 1 negative, or you can do negative 24 and 1. We just needed 3 sets of factors, but I'm going to do one more set, 4 and 6, right? Negative 4, and then maybe we'll do negative 6 and positive 4. So you can see lots of factors that would multiply together to give me negative 24, lots of factors that multiply together to give me 12. Look, if I did negative 2 and negative 6, they multiply together to give me positive 12, right? So lots of potentials. But what multiplies together to give you 0? Well, you could do 3 and 0. You could do negative 5 and 0. You could do 267 and 0. Because anything times 0 is 0. And so if your result is 0, it means that one of the two factors has to have at one point been a 0. So if you have m times n, these two things multiplying together, and your answer is 0, well, then either m is 0 or n is 0. And the zero product law helps us because if we take a polynomial and we factor it into pieces, and the other side is equal to 0, well, then you know that one of the pieces, at the very least, one of the pieces has to have been 0. So what that means for us is, what if we have some factored pieces like this, like binomials? These are two factored pieces, and the result is 0. Well, it means that either this piece is 0 or this piece is 0. Well, we need to account for both of those pieces having been 0. So what we do is something I like to call the t-chart, and we actually set each piece equal to 0 and test what would have to be the x value that would make this side 0. Okay, well, let's, solve an equation, get x alone, add 5 to both sides of the equal sign here, right? It cancels here, and 0 plus 5 is 5. So for this factor to be 0, x has to have been 5. For this factor to be 0, then let's see. Well, this side we would subtract 1 from both sides, right, to get x alone. 0 minus 1 is negative 1. So for this side to have been 0, x has to have equaled negative 1. Those are our two answers for x. If x is 5, you would get one of the two factors to be 0, and that would work. If x is negative 1, you would get one of the two factors to be 0, and that would work. What we're saying is now we could have 2, maybe 3 answers for x based on using the zero product law. And what we do to represent those answers, now that we can't just say x equals 5, it's x equals negative 1 and 5, then we put them in French curly braces like this as a solution set. Now, integers aren't the only possibilities for answers here. You can have a number in front of the x and a parentheses like this. We remember that from our factors. And notice here, this was something that was factored completely. So there's 1, 2, 3 factors. And all of them have to be set equal to 0. So I'm going to make 3 sections in my t-chart, and I'm going to set each factor equal to 0. So 5 equals 0, 4x plus 3 equals 0, and x minus 6 equals 0. Well, is 5, the number, ever going to be equal to or the same as 0, the number? And the answer is no. That will never happen. These will never be equal. And so because there is no variable present here, this is not yielding me an answer for that variable. And so all you do is you represent the fact that this variable, this factor didn't have a variable. You just represent it by saying, they can't be equal, so there's no answer here. Okay. But here there is a variable, so here we need to get that variable alone. Subtract that 3 over. You get 4x equals negative 3. Well, now to get x alone, you divide both sides by 4. You get x equals negative 3/4. So there's one answer for x that, yeah, isn't an integer, but it is still a rational number and very possible for our answer for x. Over here, get x alone, add that 6 to both sides, and x equals 6 is the other possibility. So my two possibilities for answers for x here, only two, not three, are -3/4 and +6. Lastly, with C, yeah, a GCF is a factor. So each of these is still a factor. So each of them gets a section in the t-chart where you set it equal to 0. So 2x equals 0 and x plus 6 equals 0. And again, we are solving each of these individual little linear equations for x. That's our plan. So here, well, boy, let's see. Well, to get x alone, you'd have to divide by 2, right? Both sides. But 0 divided by 2 is still 0. So x equals 0 is one of the possible answers for x. If x was 0 right here, this factor would be 0. Over here, to get x alone, you just subtract 6 over, and you get x equals -6. So there's my two answers in my French curly braces. When I make my solution set, as you can see, I always put my negative, I go in numeric order, right? Smallest to largest. So that's why I put those in the orders that I did in my French curly braces, even if my tables weren't. That's not a requirement. That's a me thing. So as long as you have all of your solutions in the French curly braces, that's fine. Let's try example 4. So pause it here. Notice I gave you options. I think you might be able to do example 4 without showing the t-chart based on A, B, and C in example 3. Think about where I got those answers from and how they related to what was in the original binomials as you're thinking about the answers for example 4. Okay, so pause it here, give it a shot, and I'll be right back. So the answer, as we can see, is choice 2. There are 2 answers for x that would make our factors equal to 0. So by extension, we're multiplying by a 0. The whole thing is 0, right? This does not yield me a factor answer, which is why choice 3 is not a good choice, because there is no variable here. This will not give me an answer. So you kind of ignore that in just your general thinking, and then just think about, well, what plugged in here would give me a 0 in this binomial? And that would be a +4, because +4 minus 4 is 0. You can kind of see where I'm going here. Then here, what would go in this binomial to add with 7 and add up to 0? And that's a -7 plus 7 adds up to 0. And what you've just figured out is the answers are going to be the opposite of the sign that's in the binomials for that reason. Okay, so that's why this is a +4, even though it's a -4 in the binomials, and a -7 here, even though it's a +7 in the binomial. You can use what I've already previously done as examples that brought you there, okay, that brought you to that conclusion. So that's something that you want to kind of think about as you're moving forward. Okay, it's going to be the opposite of the sign that's in the binomials. All right, that is applying our zero product law and making sure we have standard form. Those are the first 2 things we really need in order to solve quadratic equations by factoring. We're going to put it all together in lesson 2. But for now, on your homework, I want you to be able to get standard form of your quadratic equations. And then I want you to be able to use the zero product law to find out answers for x in previously factored pieces. Okay, so you'll have pieces like this that you'll be doing the zero product law on. Okay, we'll put it all together in lesson 2, but this is chapter 8, lesson 1. Good luck, guys. I'm sure you'll do wonderful, but ask me if you need anything.